Welcome to this first lecture of the COP 2510 Programming Concept course. As indicating in the Getting Started section, which I am assuming you're already familiar with and you read before to play this video, we are going to devote the first 3 to 4 weeks of this online course to go over very general programming concepts which are going to be the foundation for the rest of your career. So we are going to look at those concepts in very general terms during those lectures, and the lectures, which I try to keep relatively short, are going to be completed by video of hands-on practice, etc., which are going to illustrate those concepts using the Raptor flowchart interpreter. After this first part of the course, we will then move on to a more traditional setting in which you will put into application everything you learned using the Java programming language. Back to today's topic. This slide is representing everything we are going to cover in this first mini lecture. We are going to discuss about literal values. Okay, so these are really essential cross-language topics. Okay, so literal value is going to be like focused on how do you represent values, numerical values, string value, etc. inside of a computer program. This is going to lead us to the concept of data types. Values are categorized into different types. The concept of data type is really central to programming language. Data type and of literal value, we are going to link together the first two sections that we already discussed, and then we are going to move to a second very important concept in programming language, the concept of variable. And we are going to see that just the same way as literal values have data types, variable also have data types. And we will conclude by giving you a couple of pointers on what's going to come up next. So this overview here maybe seems a little blurry. This is normal because I'm telling you what we are going to cover, but I don't go into any sort of detail yet. So all those terms, literal value, data type, variable, etc., if they are new to you, this is okay. This is a class that is meant to require no preliminary programming experience. So we are going to define everything from scratch. So let's move on to our first concept, the concept of literal value. What I do when I teach this course in a classroom, usually I spend a couple of minutes asking people, well, give me example of values that you are using in your everyday life, in your professional life, etc. And generally I get things such as, well, the value 10, for example, a value that has no meaning beside, representing the quantity 10 of something, etc. I get people giving me like things like 200 feet. 200 feet is a distance. Other people are going to tell me about 0 degree Celsius, a temperature, etc. Maybe the string I don't want to program is going to come up with my student. So this is a text. Okay, you notice how, and I'm going ahead of myself here, how I have convention to write a string, okay, a piece of text with double quotes to open the text, double quotes to close the text. So these are just examples of the value I receive in class when I'm doing this kind of stuff. So the other slide is like taking a sample of them, and we are going to go over them, and we are going to try pretty much to categorize them. Informally, in a natural language, in a human language, you are using this value and you know exactly what they refer to. Well, this one is a distance, this one is a temperature, this one is again a distance, this is an Avogadro constant, this is a name, the name of someone, this is the name of a course. So you see, just in those 6 examples, we have a lot more information that we are going to usually manipulate in a programming language, at least as beginner. We have values, for example 20, 32. We have here indication of what does value represent. Okay, that is the meaning of the value. Like for example, centimeter for this one. For this one, this would be a course name. So we have already the value itself, and we have its meaning attached to it as, well, we can call it informally a type. Centimeter is a type of value. The course name is a type of value, etc. So let's try. We're going to try to have this, everyday life common sense view of values and progressively makes the transition of what it means to be a value in a computer program. What is a formalism that is used to express values in computer program. So if we start to try to categorize those values, we go to the concept of data types. So let's go back over those values. This is a list here of generic data types. What do I mean by generic data types? Well, I mean that every programming language has its own set of data types. Okay, all of them can manipulate integers. Okay, all of them can manipulate different bases of integers. So I'm going to come back on that concept of bases and how information is coded in a computer very soon. So stay tuned for that. But for now, let's just think, at a very general level. All programming language can manipulate integer in every type of base, can manipulate floating point numbers, and can manipulate string. So for now, we are going to focus on those three types of data. When we move on to Raptor, I will fill in the blanks, and I will tell you exactly what Raptor use. When we move into Java, I'm going to fill in the blanks and tell you exactly all the different types of data that can be manipulated in Java. But right now we're still trying to be programming language agnostic, so we are just thinking in general concept. If I accept the fact that pretty much all programming language can manipulate strings, floating point number, and integers, well, I look at the values that were given to me in the previous slide, and I can really easily say that, well, 20 feet from a computer program perspective is an integer. 32 degrees Fahrenheit is also an integer. So in the previous slide, when I was trying to introduce very informally the concept of type, I told you that pretty much we use types every day, okay? Temperature, distance, etc. Alright, that's everyday life. Now we are coming onto a programming system, and we have one type here, which is an integer number. So even though 20 feet and 32 degrees Fahrenheit are really different things, for a computer, the number 20 and the number 32 can be manipulated and stored in memory as integers. What about 103.27 centimeters? Well, that would be a floating point number. So I'm kind of, when I program and manipulate data, to a certain extent, I am ignorant of the real semantics of the data. Is it a temperature? Is it a distance? Is it centimeters, in feet, centimeter, etc.? No, I don't care. I care about the value I need to represent, and this is what dictates how I'm going to store it in memory, as we are going to discuss in a couple of minutes. What about 6.02, 10 power 23? Well, this is scientific notation, right? Oops, sorry about that. This is scientific notation. Scientific notation of what? Well, scientific notation of a floating point number. So we can put this guy in this category. What about the string COP 2510 programming concept? This is a text. Well, this is going to go under the category string. Alright, so let's move on. Now, we know how to sort out all those examples into types that are really close to what programming language use. Now, is there a sort of organization to all those types? Yes, there is actually. A commonly admitted organization is that every value you can use is going to either be of type, I would say, text, or of type numerical. Okay, that's a very broad classification. By text, I mean essentially strings. Okay, we'll complete the picture later. What do I mean by numerical? Well, by looking at my example, I distinguish two types of numerical value: integer, which I'm going to abbreviate as int, and floating point number, which I'm going to abbreviate as float. So that gives you an idea of, well, in a computer program, there are different data types, and these types are organized themselves in category. And this is something that we are going to really come back on when we study the Java programming language, okay, where this kind of hierarchy is going to make a lot of sense to you because it is fundamental to the programming language itself. So now that we have this little hierarchy, and I'm going to use from now on this drawing of the hierarchy here, Now that we have this little hierarchy, we have a problem. We have a problem that everything that I showed in this list is really a little rough, a little raw. I don't know exactly how to qualify it. It's not natural to most people, okay, except if you have been doing already programming and have a little bit of experience in that field. This might sound to some of you as an arbitrary division of things. Well, you have to understand that yes, this is an arbitrary division of data type, and this is the one that is the most well suited for computer languages. Now, if I go to the next slide, this is what people would use in everyday life. When you talk about a numerical data type, you want to know what type of data types. You don't care really if it is an integer or a floating point number, you care about what is the meaning of this numerical data type. So that would be a more human-centric view of things. What about strings? Well, it's really rare that people refer to strings or text just in general. They refer about a book chapter, they refer to an employee last name, a street name, a whole address. These are the data types that we manipulate in our everyday life. Once again, all of these for a computer program are going to be text to manipulate. So this is the first thing you need to do when you learn to program for the very first time. You need to try to leverage your common sense, of course. Don't leave your common sense out of the picture. It is a prerequisite for that course, okay, for this course. But as the same token, you need to realize that you cannot just attack programming with a bunch of, common sense trick and natural language expression. You need to start formalizing stuff. You need to understand how programming language express things so that you can express hopefully your real life problem into a formalism that will work with a computer, that is a program, a computer program. Okay? So I'm just trying to underline those little difference between what you already know pretty much and what you are here to learn programming, and which can sometimes hold people back a couple of weeks because they just don't get why they can just simply talk about an employee last name, a street name, and why they have to talk about a string. The good news is that as you progress in learning programming, and at the scale of this course, that means as you reach week number 5 or something like that, we're going to learn to program with Java, and we are going to progressively move toward something called object-oriented programming. And object-oriented programming is all about modeling real-life situation, modeling the fact that in a computer program we want indeed to have a data type which is a last name. We want indeed to have a data type which represents duration, etc. So view it as the next step in your learning how to program. For now, we are going to manipulate very basic stuff: strings, integer, floating point number. Then we will move on modeling more complicated data types. Okay. Now we have been trying to brush two pictures. Okay, one is what we are going to do right now, manipulating string, integers, floating point, and programming means that your real world problem need to be converted into a manipulation of those things. And then the second thing we discuss about is what we're going to do in the near future, in about couple of weeks. That is trying to model more accurately data types that occur in real world problems. Now, what I would like to insist on with this slide is that a data type means a lot of things. Okay? Every value that we use in real life have meaning. We call it semantics attached to them. For example, when you are talking about, I don't know, a dollar amount, this is my first example here, when you are talking about a dollar amount, well, you have certain expectation. Okay, if someone is talking about a dollar amount with 23 digits after the decimal point, something is weird there. Okay, if you're talking about having $1 million on your bank account, well, in the case of my bank account, there would be something suspicious about it. So, same thing for temperature. You talk about a value, minus 273 Celsius degrees. If this occurs on your thermometer, this is something weird. So my idea here, my point, is that for each data type in real life, you have meaning attached to it, and you have ranges attached to it. What makes a valid temperature? What makes a valid balance on your bank account? Okay? Well, those concepts are going to also translate into the data types that we manipulate in a computer program. What makes an integer? Well, an integer is obviously a number that doesn't have a decimal point. An integer for a computer program is also such a number within a range. For example, most computer systems would tell you that between minus 32,000 something to plus 32,000, I think it is 255. So this here might be actually, I'm just working out of memory here, so might be minus 32,256. Well, some computer language are going to tell you that this is the definition of an integer, a number between this range to that range. Okay? Now, what about floating point? Well, same thing. You will have a range, an interval inside of which the value is valid. What about strings? Well, for strings it's a little bit different, but you might have some programming language that are going to tell you that the string value cannot have more than X thousand character. Okay, so each data type comes with a certain expected meaning, certain constraints on how you write this data type in a program. Okay, for example, for a floating point number like 10.3, we always use the dot to indicate the decimal notation. We don't use, when we are talking about 2000, we use 2000. We don't use 2,000. So all of these are little syntactical conventions. Okay, how do I write this? How do I write this? If you have been learning foreign languages, you will notice that each foreign language has its own take on how a date should be written. Okay, the US way, for example, is to take the month, then the day, then the year. Over European language are using first the day of the month, then the year, finally, etc. So each language, natural language, human language, has its own take on how to write the date, how to write time, using military time or AM, PM system, etc. Well, that's a little bit what we're talking about here. You are learning to speak another language, a formal language, programming language. When you do so, you need to learn all of those conventions, all of those rules, all of those syntactical rules. Okay? So there is a syntactical aspect that we already underlined here, that we also underlined when we told you, well, you need to use double quotes to delimitate a text in a computer program. And then there are those semantic aspects, which are, well, when I talk about an integer, I'm talking about a number which has value in this range. So that leads us, and that will lead us later, I should say, to discuss the concept of encoding. Okay, so before we are done with this first lecture, you will have a little reading assignment from the textbook, which is going to explain to you all about encoding. So check the web page of this module for detail about what you need to read exactly. Okay, alright, so pretty much this slide is summarizing many things that we have been already introducing more or less informally. Okay, so yes, we want to capture in a programming language some of the aspects of data type which you are already familiar with because you deal with values all the time. However, very important, yes, we capture some of the aspects of data type as we use them in everyday life. Not all aspects. This is not the same thing. Okay? When you program, you have to have a much more formal way to deal with data types than you used to in everyday conversation, of course. This is akin to what happened when you learn math. You can, have, I would not call them demonstration, but you can have like arguments in which you are like trying to make a point in everyday life. However, when you study discrete math and you study logic, etc., you have to formalize your demonstration. This is very different. This is a difference between an everyday conversation that you can have with your buddies while watching football and actually doing something that is closer to a professional activity with some scientific rigor. Okay? Same thing here. So we already discussed a couple of aspects, semantic and syntactical. Let me illustrate with some little details here that you are going to have to get familiar with. When I want to write the value 10, well, in everyday life I just say, well, I'm talking about the number 10, okay? And that's enough. In a programming language, you cannot just do that. Are you talking about the value 10 as the integer 10? Are you talking about the value 10 as the floating point number 10? You have to be specific. Okay, so these are the rigor and discipline that you need to acquire during this programming class. So that would mean what? That would mean that when you write the value 10 in a program, you can write it like this, just 10, or you can write it 10.0. For us, it looks weird, because 10.0 is the same thing that 10. From a mathematical perspective, we can say that those two numbers are equal. No problem. Well, they're not equal for a computer system. Let me take this back. They are equal when you use them in computation. Okay? They have the same value, but they are not equal from the perspective of a data type. Which one is which? This, by the convention that we detailed in the previous slide, looks like an integer. It doesn't have a decimal point. This guy here has a decimal point. It's therefore a floating point number. Now, what is probably hurting your logic at this point is that 10.0 is the same value than 10. Yes, but it's a different data type. You have a decimal point here, and even though the following digit is not a significant digit, it's there. And this is the way you can indicate to your programming language that you are talking about 10 being a floating point number. Why would you like to do so? Well, you are going to have, like many occasions, especially when we start with Java, to understand more about data types, to understand more what are the relation between integers and floating point number, etc. When we come to this point, we are going to teach you how to transform the value 10 integers into the value 10 floating point number, and vice versa. At this point, you will have a better background, I should say, to understand why this is important. Okay, so let's leave it at that for now. What I want you to remember is simply that yes, these syntactical convention can be used sometime in weird ways. Example 10.0, just to mean that a value is of a certain data type. For 20.3, no problem there. This is clear. Floating point number. What are you doing in my swamp? That's a string. I recognize here the double quote, the opening and closing the double quote. That's a string. Then, as we learn to program in Java, we are going to bump into weirder notation. And I'm always trying to put myself from the perspective of someone that never programmed or read code in their life. That's why I use those terms as unnatural, weird, etc. After you do program for a while, these are going to be your everyday work basis. So you are not going to be any more surprised by them. The notation I'm referring to are, for example, 0xa. What does 0x mean? Well, when you write a numerical constant and you start it by 0x, that tells your programming language that you are talking about an integer in hexadecimal base, hexadecimal radix. So 0xa just happens to be the hexadecimal coding of the value 10 in decimal. This one we are much more familiar with. 10 happens to be coded in octal, base 8, radix 8, as 0, 1, 1. How do you distinguish between 0, 1, 1, which is octal for 10, and the decimal number 11? Well, if I wanted to write 11, I would just write 11. If I put a useless 0 in front of 11, this is a hint for the programming language that we are dealing with an octal radix notation for an integer. Okay, and finally, this is also equal to 1010 in binary. So depending on the programming language, this convention here, adding a 0 in front mean octal, adding a 0x in front mean hexadecimal, and etc. Those conventions might change a little from programming language to programming language. Okay, most recent programming languages are pretty good about trying to keep the same convention and over, thus facilitating the job of programmers to learn many different languages. But this is not the important thing for today. What is important for today is to understand how those syntactical notation are used by the programmer to be very, very, very specific about what is written. One of the best skills you are going to learn by learning to program is to be able to read documents in a very, very rigorous way. You cannot read code as you are reading a novel. You need to pay really attention to every single detail. Okay, so to finish with this slide, the idea of type as we are going to use it in programming language, well, we are going to have integer. Integer common types for programming languages such as Java will be short, int, long. So we'll have three actually integer data type in Java, more than that actually, but three types that are distinguished by what? Well, an int is a regular integer, let's start by that. A short is an integer that can contain a shorter, a more narrow range of value. And a long, on the other hand, is an integer that can contain a lot more data, bigger number. Floating point number, same thing. A float will be your basic floating point number. A double will be a double precision floating point number. This is really important. Those two first category here are really important. Why? Because they tell you something about data types that we just tried to sketch out so far. Data types in computer programs are bounded. There is so much room in a computer memory used to store an integer to store a value, which means you have to follow this idea of range that I already gave you in the previous slide. What is the difference with mathematics? What is the difference with everyday life? Well, in mathematics, when you consider an integer value, it can have any possible value from minus infinite to plus infinite. Computer programs do not have infinite memory to store those values. Therefore, when you talk about an integer in a computer program, depending on the programming language you are using, you will have limits as to what value can be expressed validly as integer in that programming language. This is one of the main, I would not say quarrel, but I would say difference between mathematician and computer scientists. Mathematicians manipulate numbers in absolute. Computer scientists manipulate numbers in a finite precision, which means you cannot go more than, 20 digits after the decimal point to represent the accuracy of a given floating point number. So this is a very, very important concept. We'll have time, however, to come back onto it. Keep in mind, this is just an introductory lecture given, which purpose is to give you a sort of tour of the main concept related to data types that we are going to discuss in this class. Next on the list, the single character A. Well, that's a new one, okay? We already discussed about string, and I showed you how to represent a string in a computer language between double quotes. Well, what if I use a single quote available on my keyboard? Well, this is going to delimitate a single character, okay? And that's pretty much with all of these data types, we are pretty much well armed to move on to any type of programming language. Okay, so we are done with literals first, the idea of data types. Let's try to conclude this aspect of the lecture by bringing together literal and data types. What we have so far, literal values can be written in computer programs by following some syntactical convention. 10 is an integer. 10.0 is actually a floating point number. This is a string. A is a single character. Okay, so these are like the main convention I want you to remember. Then we discussed about hexadecimal, etc. We'll come back onto that very shortly. But for now, keep these as a good example of what we have been talking about in this slide show so far. These values belong to data types which the programming language can manipulate, and as such have characteristics such as the range of possible values, the lowest value, the highest value. Keep in mind to remember this aspect. An integer in math, it's anything between minus infinite plus infinite. Okay? In computer science, in computing, this is going to be, for instance, on a specific computer and a specific language, anything between something in the line of minus 32,000 to plus 32,000. Okay? Major conceptual difference here. I would call it infinite arithmetic here, finite arithmetic for computer scientists. Okay, so what do we make out of this? Well, we have been focusing so much on values so far, but what do you do with those values? Well, any sort of programming language, no matter how complex, no matter how easy and trivial, is going to allow you to do computation. For example, compute 2 plus 2. So we are using two integer value. We are using an arithmetic operator, okay, the plus arithmetic operator, the addition arithmetic operator, and we are just instructing our program to compute the value of 2 plus 2. Two data value, okay, apply the operator to them, this yield to a result. What do we do with this result then? Well, we can display it on the screen, we can store it onto disk, we can send it over the internet to another program. I could go on and on and on, okay? The idea is, yes, we can make computation between value using arithmetic operators such as plus, minus, multiplication, which is represented by the star, division, which is represented by a slash, a forward slash symbol, modulo operator, which is a remainder of an integer division and which is represented by a percent sign, etc., etc., etc. Okay, we're going to discuss all those operators as we dig in the Raptor and Java programming language. So you make those computations happen, you evaluate pretty much arithmetic expression, and then what do you do with the result? Well, like I said, many choices. However, important thing to note, if we just compute value and we just, display them, get rid of them, send them over the network, etc., that's maybe good for a certain category of application. Like, for example, a scientific calculator on your computer would do exactly that. Compute a result, display it on the screen. This is all you need pretty much. What about when you have application which need actually to keep the result of previous computation handy? For example, when you're typing an email, your email client is storing actually everything you type in memory somewhere. A word processor, same thing. You are storing your text in memory before you decide to save it to disk and turn off your computer. A budget software will ask you to input all of your expenditures and then store them in memory, use this value to compute the balance of your bank account, etc. So far we have been really focused on only values. We were like really at a low level of the big picture. Now let's take a step back and try to think about what we do with those values. Well, we want to store them in memory. Compute 2 plus 2, store it in a variable named A, for example, and then use again the value of A, the current value of A, in another computation, etc. So that brings us to the concept of variable, which is going to be the next one we are going to discuss right now. So, next concept, still in the line of manipulating data, we learned about literal values, okay, we learned about the data types they belong to, we learned about operators very briefly, and now we learned about expression, which allow us to compute values out of a set of values and operators. Well, now let's learn about variable. As an introduction to variable, the only thing I would say is the purpose of a variable is to store a value, to store some data. More specifically, and this is really geared for people that are programming for the first time, when you have a variable, think about variable in mathematics, okay, like for example x. Well, when you have a variable x, you can store maybe inside of this variable a value, okay. Let's say let x be 99. That would be a statement in a math problem. So now inside of the variable x you have the value 99. Well, if later on, while you solve your problem or while you read the description of your problem, something is saying, well, x is now 200, guess what happened? X can have only one value at a time. Okay, this is common sense, this is mathematics, this is really basic stuff. So if x can have only a value at a given time. At the beginning it was 99, right now it is 200. So if I use x in over equation, well, now I'm using the current value 200. Okay, and that's the main thing you do with variable. You store value inside of them, and then you use those value for making over computation to keep our pseudo-mathematical bridge, you know, like our analogy with math. You would have variable y is now equal to x plus 3. So what would that be? X is currently containing the value 200, right? So x is 200. So writing x plus 3 really boils down to writing 200 plus 3. What is the value of 200 plus 3? 203. This is now the new value for variable y. So somewhere I have variable y, and it contains now 203. Okay? This is very basic stuff, okay? So now that we know what is the purpose of variables, how do programming language, and once again I'm talking really general here, any programming language lets you use variable in your program, what can we do with them? So the first thing we can do with variables, of course, is assigning values to them. If they are meant to store value, well, we need to have a way to express in a programming language, a syntactical way to express that we want to store this value inside of this variable. Well, what you have here on the side is 3 different ways to write the same thing. Where do those notation come from? Well, they come from different programming languages that evolved over the years, you know. Some programming language, for example, of the Pascal, Ada, modular family, used to have a mathematical operator, an arithmetic operator called assignment, which was noted as a colon immediately followed by an equal sign. Every time you encounter this in a programming in a program, that meant I'm trying to assign this value to this variable. That's how you read it. Variable A is assigned the value 2 plus 3. So sometimes assignment like this are going to be straightforward. A is assigned 3. Well, okay, it's easy. This is my value, this is my variable. Once I execute this statement, this operation, the variable A now contains 3. Sometimes it's a little bit more difficult. Variable A is assigned 3 plus 2. Why is it more difficult? Well, I need to compute something. I need to do some work. This is not a value. This is an expression, an arithmetic expression. So I need to execute the operator plus on the two operands 3 and 2. That leads to the value 5. Then the value 5 can be assigned to the variable A. There we go. Sometimes it's even more complicated. For example, let me make some room here. For example, you would have something such as A is assigned B plus 3 minus 1. Well, what is the difference? This is an arithmetic operation right here. Basic stuff. Okay? This is another variable. So in this case, I'm assuming that I have already in my program a variable B. Let's say it's equal to 2 right now. And I need to figure out what is the value of B. 2. I add 3 to it. I subtract 1. And then I evaluate this whole expression, and this is what I'm going to store in the variable A. So that's going to be, final result is going to be 4. Okay? Alright, so this is a general idea behind assignment. What you see here, different notation used over the ages, I should say. The arrow that points to the left was used mainly by people when writing pseudocode, when writing actually programs, algorithm on paper before to go ahead and code them in any programming language. So this was a very traditional notation convention. Okay, you would put the name of the variable, is assigned, this is how you would write this assignment operator, 2 plus 3. Okay, most modern language, including Java, which we are going to study, have now decided that the equal operator would do that job. So a equal 2 plus 3 in a programming language is read as the variable a is assigned the value 2 plus 3. So, warning, that means there's a side effect to this. That means that when you talk about equal, the equal sign in a computer programming language, you are not talking about equality. In math, if you write a equal b, that means pretty much are these two things, two variables, equal. In computer science, in programming, when you write a equal b, what you just wrote is the current value of variable b is assigned to the variable a, which is very, very different. Comparing things and assigning the content of one to another is very different. So how do you write equality in a computer language? Well, it depends on the computer language. Once again, if you are using Pascal, which has this colon equal as assignment operator and which doesn't use equal, well, there's no problem. Equality is simply the equal sign. If you are using Java, which uses the equal sign already to mean assignment, then equality would be indicated by a double equal sign. Is 23 equal to 57? Well, this is how you would write this condition. 23 equal 57. Okay? Alright, so we'll have time to go once again over all of those little syntactical detail as we progress through this course. Okay? I'm just warning you ahead of time about all the little glitches that might cause you some problem understanding the big picture. The general syntactical diagram of an assignment operation is always the name of the variable, followed by an assignment operator, whatever is the convention in your language, okay, just read the documentation, followed by an expression resulting in a value. We are going to use a lot of these syntactical diagrams, especially when we learned Java, because they are a nice way to provide you with the rules of the programming language. Just like a natural language has vocabulary and grammatical rules, a programming language has vocabulary. Example, what is the assignment operator? Well, in Java it is equal. Consider this to be your vocabulary learning assignment. You need to learn this by heart. There is nothing to really understand there. And then what are the grammatical rules to do an assignment? Well, first, name of the variable, then assignment operator, which is equal, then expression resulting in a value. So, very much, it's really important that you approach learning a programming language to a certain extent as learning a language. It's much more formal, of course, but there are still a couple of things that you can leverage through analogy. For example, I need to learn my vocabulary. For example, I need to learn my grammatical rules and remember them. If you do not remember these, just like you cannot speak German if you don't remember the structure of a sentence and the words in German, you cannot program if you do not remember the syntactical and the grammatical rule. This is a necessary condition. It's not a sufficient condition. Once you learn that, you will also have to learn a very important skill, which is how to solve problems. And this is a skill that is language agnostic. It doesn't have to do with any specific language. Yet, if you don't know how to express things formally in a programming language, you do not know how to program. Okay, we are nearing the end of this lecture. What can you do with variable? We just, previous slide, I'm going back real fast, we just discussed about, well, we can assign them value. Now we can also do input-output operation with variable. And this can be very, very general. This can be, writing the content of variable into a file. This can be sending information to a web server or something like that. We are going to keep it simple for our beginning steps in programming. So we are going to deal mainly with displaying the content, the value of a variable on the screen. Displaying maybe something a little bit more complicated, which is a result of an expression combining variables and literal value on the screen. So that would be, for example, for the first example, we would talk about and let's say that our language allows us to use a command word display variable a. In this case, that would be display the result of the expression a plus 3 divided by 30. Okay, you see the difference. We display a single variable content, we use the content of a variable in an expression, and we display the final result of this expression. Displaying on the screen is half the job. Reading value is the second thing we are going to do. So typically we want to read a value from the user of your program through the keyboard and store it inside of a variable. So now, keep in mind, as we already explained in the Getting Started section of this course, that those mini lectures are there for you to learn concept. So I'm telling you right here, we are going to display values and read value. I'm not telling you how we are going to do it. This is going to be detailed to you through our hands-on exercise using the Raptor flowchart interpreter. In a couple of weeks, when we make our move to Java, I will tell you again how you do those things in Java. And in the next 10 years of your career, every time you will have to use a different language, you will know already what you can do with variable, you will know the big concept, the big picture, and all you will have to do is learn how you do it in that specific language. Okay? You all know how to order food at a restaurant. When you go in a different country, you have to learn the vocabulary and the grammatical structure that are going to allow you to formulate such a request in that specific language. Okay? Same thing here. Let's move on. Now, we are going to discuss relatively briefly something that is really important. It's pretty much a definition of what a variable is from a computer system, a computer program point of view. So we are trying to get a little bit more technical. Why? Because you can reason on variable in an abstract way, but then it makes it difficult to understand why can't I store an arbitrary large number in an integer variable. Okay? Well, if I explain to you what is a variable from the perspective of the computer, then you will naturally understand all those characteristics, constraints, and limitations associated with variables in computer programs. So let's try to do this. First definition, a variable is some space in memory used to store a value in it. This means that a variable is located somewhere in memory. It is actually a good idea to imagine, and I cannot draw a straight line, sorry about that, but to imagine the memory of a computer as being a tape which is going to be divided into chunks. Okay, and for the sake of our example, I'm going to say that each chunk is actually, sorry about that, is, well, let's call it a word. Okay, not a word in the sense of, a word in a paragraph in a book. No, a word in the sense of a unit of storage. So you probably all know by now that everything is stored in binary in a computer. If not, the reading assignment that you will have inside of this module is going to point you to chapter and section in the textbook that are going to explain that very well. So maybe I'm anticipating a little here, but just stay with me for the sake of this explanation. Everything in a computer is stored as a series of 0 and 1. This is why you will hear people mention that I'm storing this integer value in a format which is called binary. Instead of writing it 1, 0, okay, I'm going to write it in binary, which means maybe 1, 0, 0, 1, 0, 1, 1, 1, 0, etc. Okay? And this is what's going to be stored in memory. Same thing when you store a character. When you store a single character like the letter A somewhere in your program, this is going to be stored as a sequence of binary digits in memory. So, assuming your memory is a ribbon, each word here is going to be able to contain a certain number of bits. Okay, bits means binary digit. That would be like one of those digits in a binary value. So, for the sake of this example, let's say that each word is 32 bits. this is how our memory looks like. A ribbon divided in word. Each word can contain 32 bits. So if I say one integer needs 32 bits to be coded in memory, that means one integer can fit in one of those guys. If I say this particular string, which is 2000 characters long, needs, well, X words to be stored in memory, that means that somewhere in the memory of my computer I'm going to use X words to store my long string. Okay? So when you think about a variable, try to visualize this ribbon, the memory. Try to think that depending on its data type, the variable is going to take more or less memory to be stored. An integer will take only this much, a single word. A long string will take this much, many words. Maybe a floating point number will take 1, 2, 3, 4 words to be stored, because you required good precision. Okay, you want to be able to store a lot of significant digits after the decimal point. So that would be my int. That would be my string, which I abbreviate str. That would be my floating point number. Okay? So try to visualize things like that. If you have this picture in your head, then the variable appears simply as a location on this ribbon. How do you specify the location on a ribbon? Well, you start by numbering all of those units of memory, all those words, starting at 0, 1, 2, 3, and you keep like that. You keep going like that. So maybe when you talk about this particular int here, from an internal point of view, the computer is going to think of the word of data, that's the size of my variable, located at address 3. When you are talking about this variable here, and let me change in color because this is really getting difficult to follow. When you are talking about this variable, in color, this variable here, you will talk maybe about this size of memory, 1, 2, 3, 4, 5, 6 words. That would be the size, starting at address, let's say 103. And that would completely qualify your variable. That would be a way for the computer to keep track of this particular variable. Last one, let's say that this is 130. Okay, this is a 130th word of memory. Well, the variable here is comprised of the 1, 2, 3, 4 words starting at address 130, and this is a float variable. So you see now maybe how the type of a variable is a good indicator, is good at giving you a constraint about how big in memory this variable needs to be. It's also good to tell you how you can read the value inside, because without entering the detail at this point, if you store everything in binary, you need a way to encode different data types. An integer will be coded in a certain way in binary. A string will be coded another way. Each character of the string will receive maybe a code, as 1 byte. A float will be coded differently as well. So this is what a type is really useful for from the computer perspective. You manipulate variables, I need to know how big they are. I need to know what they contain so that I can decode the value back and forth between binary and whatever it is that your data type is, int, string, float. And then what? Well, and then do you want to use memory addresses all the time? The answer is no, because that would be really like, I would say, helping you cause more bugs than you need to in your programs. So you want a easy way to relate to a variable, to refer to a variable. Just like in math, you talk about variable x, y, z, variable maybe name for an employee name. Well, we call that an identifier, the name of the variable. Okay, so you will be able to say that this variable here, this string, the name of this variable is employee emp name. And that's it. That's my identifier. That's the name of my variable. I don't care anymore suddenly about where it is located, what is its address. What is the type of employee name? The type of employee name is data type string. And I don't care anymore about what is the size of a string in memory. I am abstracting. I went down with you at the lowest detail to explain to you how things were encoded in memory, etc. And now we are taking a step back, which is what we're going to do every day in our programming activity for the upcoming semester. I manipulate variable through their name, and I know how to manipulate them and what to use them for because of their type, string. So, when you use variables, now that you have a better idea of what is a variable is a name, an identifier. A variable is a type. A variable is located at a specific address and occupies a certain amount of memory. Well, now that you have this better vision of what a variable is, how do you declare a variable? How do you say I need a variable A of type integer in a programming language? Well, this slide is almost empty because from the generic concept point of view, I cannot tell you much about this step. I can tell you only that yes, many programming languages ask you before you start using a variable to declare it. What does it mean to declare it? That means giving all of this information about the variable. Okay? For example, to be concrete, in the Java programming language, you can write int a semicolon. This is a statement which declares a variable. The variable name is a. The type of the variable is int. The language doesn't need to ask you for an address or doesn't need to ask you for a size. Because you said a is of type int, immediately Java knows that in memory it will need one word to store the value of this variable. This word of memory might be located at address 199. Well, that's fine. From now on, whenever you use the identifier A, the Java language will understand you are talking about this particular word of memory. And that's it. Whenever you store something, whenever you assign a value to A equal 9, Java will take the value 9, convert it in binary, and store it inside of this word. Every time you are trying to use the value of A in another statement, okay, for example, display the value of A. This one is not Java. Okay, I'm just trying to be general here. Display the value of A. Well, Java is going to retrieve the content of the variable A at this address, read the content expressed as binary bits, and convert it into a value that can go on your screen. And on your screen you are going to see the value of A appearing as 9. Okay? So, that's pretty much it. Now, if I want to go further, I need to teach you not what declaring variable is about. I need to teach you how to declare a variable in Java, how to declare a variable in Raptor, etc. So in this module we are not going to touch Java very much yet, but we are going to learn to use variable with the Raptor system. Manipulating data, going a little further. So we are done with the main concept. What I want to do now is, through 3 slides, I want to give you an idea of what's coming up next. Okay? So first, we mentioned many times, the need for encoding in binary a value that is, for example, 10 or 10.3, etc. Well, this is generally a topic that is covered in courses named Computer Organization, Computer Architecture, because these are courses that go at a very low level in the way computer works and explain to you how things are stored in memory. For an introductory programming class, I do not want to go too deep in those technical level, at least right now. So I'm going to give you a reading assignment from your textbook, which is going to explain the basics of coding values in different radix, in base 10, in hexadecimal, in octal, etc. And this would be what we start with. Okay, then if you continue in computing, you will have like courses that are going to go much further, and if this is your only computing course, well, you will have at least a basic conceptual understanding of what's going on under the hood, so that you can adapt to the many languages that are going to flourish over the upcoming years. Going a little further again, what about grouping variables? One tacit rule that we use so far is that each variable A for example, can contain only one value at a time. So A is an int, it can contain the value 20 and only the value 20. The next thing we are going to do in a couple of weeks is consider variable, like variable B for example, which contains multiple value. For example, 23, 9, 200. These are pretty much arrays. This would be an array of integer. You can have array of integer, arrays of floating point numbers, arrays of string if you need to. We refer to those variable as sometimes aggregate variable, and the opposite of an aggregate variable is a scalar variable. So far we have been using only scalar variable. In all the exercise we have for this week, we are going to use scalar variable, and we are going to progressively move our way up to arrays. By the time we learn how to deal with arrays, we are going to be ripe to move on to Java. So we will move to Java, we will explore again scalar variable, then aggregate variables such as arrays, and then we'll go much further. We'll go into things called classes, which belong to object-oriented programming, to the object-oriented programming paradigm. Going a little further, last one, and this one is not new stuff. It's just putting a label on things that we already covered during this lecture. I told you we can declare a variable. My example was in the Java language, int a semicolon, declare variable a of type integer. We can assign a value to a variable a equal 23. That would be Java as well. A equal 23 semicolon. Well, what are those? Those are referred to as statement, and you heard me already use that term in the previous in this lecture. A programming language statement, you can see it as an individual step of computation. I'm working on computing something. Step 1 is declare a variable. That's a statement. Step 2 is assign the value 23 to the variable a. That's a statement. What else is there to learn? Well, part of learning how to program is to learn what you can do with a programming language. So pretty much to explore all the different type of statements that are available for you to use. We already saw declaring variable, assigning value to variable. We mentioned, the capability to display things on the screen and to read values from the keyboard. Well, this would be input-output statement. In the upcoming week, we are going to start discussing conditional statement, if statement, and then we are going to discuss as well loop statement, how to repeat a certain computation a certain number of times. Okay, for example, repeat displaying on the screen the value of a until somebody press a key or something like that. Okay, so this is going to be our roadmap. In this week, we are going to focus on declaring, assigning, and doing some input-output using the Raptor flowchart interpreter. In the next week, we are going to add on to that new type of statement, conditional statement and iterative or looping statement.